want to look at some of the specifics of middleware that are relevant to object orientation. Okay, so we want to look at some of the design considerations, some of the things, additional things you need to think about when you're object oriented, when you're writing a program that's meant to be distributed using an object oriented language. So we need to think about references, the idea of activation and deactivation of objects, persistence, whether we use it or not, and how we would use it, latency of requests, concurrency, how's that handled, communication, failures, and security. So within a normal computer program that you would write that's not distributed, so references to objects are usually pointers to memory addresses. And usually those are very, very small in memory. So they hardly take any space at all within memory, and we don't really think about them too much. So you just create your classes, you create your objects. The runtime environment handles the creation of those objects and deletion of them. And we don't really worry about the performance of the computer program, no matter how many objects we would create, because it's not that great for programs that are meant to run on a single machine. However, references to distributed objects are much more complex, but we also need to think about the URL. So if I want to point to a certain memory address in a certain machine, then I need to add this additional information, which substantially increases sort of the footprint of the pointer within memory, and that's something you need to think about. So references to distributed objects are large, and they're in the 20 to 30 byte size. When you're storing references within a single program or a single machine, then it's much smaller than that. So it's typically less than a byte. So you don't really want to be making lots of reference calls between different parts of the computer program that are distributed between different machines, because it can, if you have lots of objects, lots of parameters, then it can substantially affect the performance of the program and the space that it would need to run. So we need to think about the life cycle management of our program. So again, that's something you don't really think about unless it's a very specific type of application. You don't really think about it when you're running a program on a single machine. So within object-oriented programming languages, your objects reside in memory, or as it's called, it's virtual memory between their creation and destruction. So that whole happens automatically in the background. But for distributed objects, typically applications are much larger, and you have a much larger number of objects. Also, objects might not be used for a very long time. So as an example of that, think of let's say you go onto a website and you want to create your profile. Nowadays, whenever you want to join any website, like let's say you want to buy insurance, usually there's a page somewhere where you have to type in all your personal details, your name, your address, for example, your house details if it's insurance for your home. And sometimes these forms are so large that you want to be able to leave the website and come back to it later. So you need to think about the activation and deactivation of that particular object. Another thing that you might need to think about is that some hosts might have to be shut down without stopping all applications. So you might have the application running redundantly on different servers, and you might need to do maintenance to some of your servers. So what happens to the objects in the servers that you need to shut down? So you need to have some kind of a mechanism to take all those objects that are stored on the server within the memory of that server and to save them, basically, and then to reinitialize them either within the same server later on or within another server if they need it immediately. We've got this idea of activation, where you explicitly or implicitly have to bring objects into main memory. So you bring them from some kind of persistent storage, and you have the idea of deactivation. So you need to be able to discard objects from main memory and put them somewhere for safekeeping for later on when the client logs back into the system, for example, or when they reinitialize a form that they want to refill, or whenever they want to do, or whenever they want to continue shopping, using like putting more objects in the shopping cart. So these are things that you need to think about. What do you do with your objects? Several questions arise from that. What kind of repository do you use for your implementation? What type of database? That largely depends on the application that you're trying to run. Do you use a database at all? Do you just persist things to some kind of filing system? Another thing that you need to think about is you don't want to just store things randomly into various databases, into a file system. You want things to be logically stored, depending on what processes are running at the time. So you need to have some kind of association between your objects and your processes. So then that relates back to the design of your application and having the correct logic. Explicit versus implicit activation. When do you initialize an object? Do you initialize it when a user logs back into the system? Do you just initialize all their objects, or do you allow them to explicitly load their objects by having a load button somewhere, or do you require clients to explicitly have some kind of explicit interaction with the application, or is it something that you decide? It largely depends on the application and what you want to do with it and how you want it to perform. When do you want to activate the objects? How do you treat concurrent requests? Do you allow multiple interactions with the same objects, or do you not allow multiple interactions? Do you lock your objects, or do you not lock your objects? So so you need to learn how to use transactions. If you want to allow concurrent requests, and so you need to manage the process somehow. And all these things can be decided at various stages and various levels. So you can. All these things can be decided by the designer of the application before it's been implemented, or it can be decided by the programmer at the programmer level, or you can allow the administrator to have lots of different options, depending on who's interacting with the application, what type of network it's running on, how many users are using the application. In which case, you give the administrator control, and they can configure the application depending on who's using it. So that makes the application a lot more complex. Looking at some of those things a bit more closely, so obviously persistence is something that you need to think about. So objects have to save their state between object deactivation and object activation, so onto some kind of persistent storage. And you can do this in two different ways. You can map it to a database, or if it's a simple application, you can just save it to some kind of filing system. So this is usually decided at design time, so something you need to decide before you actually set about implementing the application. Another thing that you need to decide as a computer programmer, or think about as a computer programmer, is how objects call each other and how they're being transported across the network between different parts of your application. And that's because you need to think about the latency of your requests. When you write a program on a single machine, so local method calls usually require a few nanoseconds, or in the range of a few hundred nanoseconds. When you're making method calls across machines, then that jumps in scale. It goes to the millisecond scale. Method calls and the transport of objects slows down substantially. So the best way to implement distributed applications, therefore, is not to have very chatty applications. You want to reduce the number of method calls as much as possible, and instead of that, you want to perform coarse-grained tasks. Okay, so you want to be able to lump a number of tasks together and transport them across the network together where possible. So another thing that you need to know about is how method invocation happens. Because if you have your application, your distributed application, to be synchronous only, then it's going to slow it down substantially. So you need to think about having other ways of running your methods in addition to that. So you can have one-way requests, you can have deferred synchronous requests and asynchronous requests. So first of all, synchronous requests. So this is the simplest mode of interaction you can have. So the idea is that a client makes an operation request at the server and then waits for the server to complete running that operation. And in the meantime, they don't do anything. So that means that the client is sitting around waiting for ages before the server completes the operation and sends the result back. So this is fine for if you're running some kind of if you're splitting a job between several different machines on a local area network where things are happening very fast anyway. You're not actually going to the outside internet. So you've got a very reliable, very close-knit sort of network with machines connected to each other. So in that case, it's fine to have such an application because you're not really. It's not a slow application anyway. It's usually things are running very fast, but it's not the most suitable type of interaction if you've got an application distributed over a larger network. Instead, we've got another of different options. So one option is to have one-way requests. So the way this works is that you return control to the client as soon as a request has been taken by the middleware. So the client and the server are not synchronized in any way. So you only would use this if the server does not produce a result. So you're telling the server to do something and there's no actual data being transported back to the client. So an example of that would be a print job, for example. So you're just telling the other machine to do something, and you don't need a result back. So you might want to use one-way request for that, and any failures can be ignored by the client, so you don't really worry about. You can check manually later on if the machine is fulfilled its job or not. So another type of requests you can have are deferred synchronous requests. So the way these work is that you return control to the client as soon as the request has been taken by the middleware. So the client makes an operation request, and then as soon as they make the request, they take control back here, and then they carry on doing whatever they need to do at the client side. And then whenever the client's finished doing what they're doing, they've got some spare time, they initiate an operation on the server side called get result, for example, and if the server's got the result back, then it returns the result. So the idea is that the client initiates all synchronization in this type of application. So you would do this if requests take a long time, and you don't want it. So you don't want the application to be synchronous. You want it to be asynchronous. So if the requests take a long time, then you want to do something like this. And you also would do it if the client should not be blocked. So the client requests some kind of operation, but they need to continue doing whatever they need to do. And also you would do this if the client can bear the overhead of the synchronization. So it's the client's job to keep contacting the server and asking for results back. So they request from the server, they request operations from the server, and they also ask the server for the results of the operations that they've asked for. And the most common type of asynchronous or the asynchronous type operations is the simple asynchronous type request. So in this case, again, you return control to the client as soon as a request is taken by the middleware. And in this case, it's the server that initiates the synchronization and not the client. So the server initiates synchronization by explicitly calling an operation provided by the client. So the client allows the server to interrupt them. So you would only use this if it's okay for the client to be interrupted. So the server, whenever they're finished, they just call this callback operation, and they use it to transport the result of the operation request back to the client. So you'd use this if requests take a long time. Again, you don't want it to be synchronous, and also the client should not be blocked, and again supported by Koban and other types of middleware. So yeah, so these are the main modes of operation that you can have within middleware. So you can have synchronous requests, one-way requests, deferred synchronous requests, and asynchronous requests. Another thing that you need to think about when you're designing and implementing distributed applications is the concurrency of the request, so the concurrency of how operations and objects are being called within those applications. So execution object-oriented programming languages is often sequential. However, within distributed objects, it's almost always concurrent. So things are happening on several servers at the same time. So there are multiple operations, and it's very difficult when that happens to actually predict what's going on and what could happen in the future. And a lot of errors can happen, and a lot of things like deadlock can happen, and liveness errors. So there are two types of concurrency that you can have. You can have concurrency between the processes, and you can have concurrency between the objects. So the one that we've talked about so far is when you want to have some kind of concurrency with objects. So you want to allow several threads to be able to access an object at the same time. So you need to think about, is it a read thread or is it a write thread? If it's a read thread, there's no problem. So multiple threads can read from the object at the same time. It's not going to affect the state of the object. But if multiple threads are trying to write to the object, then you do have a problem. So you need to control access to your object, apply things like transactions. Another thing you need to think about is concurrency between processes. One type of tool that distributed application programmers use are software verification technologies. And what they do is, before they actually go ahead and implement the application, they first design it, and then they create a model of the application. So the problem is that you have multiple threads running at the same time, and you want to be able to predict different sequences, and you want to check that none of the sequences will result in the application crashing or some kind of a deadlock as much as possible. So within distributed applications, we need to think about failures in the same way that we need to think about them for any type of application. So the problem is that distributed object requests are more likely to fail than local method calls, because we're traversing a network and errors happen on networks. And when you're writing an application, you need to write it in a way where a client has an obligation to validate that servers have executed requests, meaning that you don't carry on until you've received the acknowledgement. You don't assume that something's completed until you know for certain that it is completed by receiving an acknowledgement or some kind of response. And it's up to you to decide what kind of middleware you want to implement depending on the application that you need. So you can, so your reliability semantics can be either exactly once, at least once, or at most once, depending on the application that you're running. And something that you definitely need to think about when writing distributed applications is security. So when I'm running an application on a single machine, and normally the way it works is that I log on to Windows once, and then I can run any application that I want, whether it's Microsoft Word or start a web browser. So I can start and initiate any of these, and there's no problem with that because the machine's already verified that it's me. But when applications are running in a distributed fashion, they need to continuously check who's trying to access the application, because usually there's no physical person sitting at the machine. Usually it's just different applications talking to each other, sending things over a network. And how do I know who's actually accessing my server? It might be somebody trying to hack my server, or it might be a genuine application, I don't know. So we need to build these things into distributed applications. So things we need to think about are who's it that's actually requesting the operation request. So we usually handle that by passwords or by some kind of other authentication mechanism. How do we decide whether or not to grant the subject the right to execute the service? You have different levels of authority, and depending who it is that's logging on, we'll be able to do different things with the system. So for example, when I access NES, I have different levels of access than you guys do. So you have access to you can see your modules, you're able to submit coursework, you can see coursework deadlines. I can do more than you. I can see all your marks, for example. I can see when you've submitted coursework. I can also go to the exams section of NES and enter marks, for example. The head of school will have more access than me. He'll be able to see all the students in the school, whereas I'll only be able to see the ones that I'm actually teaching. So it's up to you to set the different levels and build that into your application. And the most difficult thing to do for a distributed application is how can we prove that we have delivered a service so as to make the requester pay for the service. So this is something very difficult to do. So even if a provider of an online service says that they have done it, any client can turn around and say, well, I clicked the download button, but I keep getting an error message. It's one of those things that hasn't really been solved within distributed applications, and it usually comes down to an issue of trust and reputation. So most online providers, what they do is they for their reputation's sake, they just almost always trust their clients, and they just provide the service again, or they provide another link and they allow somebody to download something multiple times or to use the service multiple times, just to ensure that they actually get the service that they paid for, even though sometimes the client might be malicious and they might have already gotten the service. So it's something to think about when you're designing your application, and when you're thinking about trust factors and the reputation of the service that you're actually trying to create. Those are important concepts and important issues that you need to think about when you're designing applications, distributed applications using object-oriented programming languages.